Imagine a world where the very air around you is filled with tiny invisible computers. I'm not talking about science fiction. I'm talking about smart dust. And it's already here. What if I told you that particles smaller than a grain of sand could be watching, listening, and sensing everything you do? It sounds like something out of a futuristic thriller, but the technology is real, and it's developing at an astonishing pace. Today, we're diving deep into the microscopic world of smart dust. We'll explore what it is, how it works, and the incredible, and sometimes terrifying, ways it could change our lives forever. Are these tiny specks of technology the key to a safer, healthier future? Or are they the ultimate tool for undetectable mass surveillance? Let's find out. So, what exactly is smart dust? Picture a sensor so small it can float on a breeze, yet powerful enough to collect and transmit data. These are MEMS, or micro-electromechanical systems. Think of them as complete computer systems with sensors, processors, and communication hardware, all packed into a volume of just a few cubic millimeters. They can be designed to detect almost anything: light, temperature, vibrations, chemicals, and even biological agents. And because they're so small and light, they can be scattered like dust, forming a vast, invisible network of sensors that blankets an entire area. The individual motes, as they're called, communicate with each other wirelessly, passing information along until it reaches a central collection point. It's like creating a digital nervous system for the physical world. This isn't just a concept on a drawing board. Labs and companies around the world are actively creating these incredible devices, pushing the boundaries of what's possible at a microscopic scale. The origins of smart dust can be traced back to military research, and that's where some of its most powerful applications are being developed. Imagine an army being able to deploy a cloud of smart dust over a battlefield. These invisible motes could settle across the terrain, tracking enemy troop movements, identifying vehicles by their heat signatures or vibrations, and even sniffing the air for chemical weapons. This provides an unprecedented level of real-time intelligence without risking a single soldier. The sensors could be dropped from a drone, an airplane, or even fired in an artillery shell, creating an instant ad hoc sensor network. This would give commanders a godlike view of the battlefield, turning the tide of a conflict before it even begins. Beyond surveillance, smart dust could also be used for equipment monitoring, checking the status of vehicles and weapons in real time to predict maintenance needs and prevent failures at critical moments. But the applications go far beyond the military. In the industrial world, smart dust could revolutionize safety and efficiency. Think about a massive factory or a chemical plant. A network of smart dust sensors could be deployed through the ventilation systems, constantly monitoring for gas leaks, pressure changes, or temperature spikes that might signal a potential disaster. This early warning system could save lives and prevent billions of dollars in damage. In agriculture, smart dust could be scattered over fields to monitor soil moisture, nutrient levels, and the presence of pests on a plant-by-plant basis. This would allow for hyper-precise farming, using exactly the right amount of water and fertilizer, leading to higher yields and a more sustainable food supply. The possibilities are truly transformative for nearly every industry that relies on monitoring physical conditions. Perhaps the most exciting and personal application for smart dust is in the field of medicine. Imagine swallowing a pill that contains thousands of microscopic sensors. These motes would travel through your body, monitoring your vital signs, checking for signs of disease at a cellular level, and even detecting the earliest stages of cancer. They could report this information back to your doctor in real time, providing a level of internal health monitoring we can only dream of today. This digestible smart dust could make invasive diagnostic procedures obsolete. For patients with chronic conditions like diabetes, it could provide continuous glucose monitoring without the need for constant finger pricks. The technology could even be used to guide targeted drug delivery, ensuring that medication goes exactly where it's needed, increasing its effectiveness and reducing side effects. It's a future where medicine is not just reactive, but truly proactive and personalized. The environmental applications are just as profound. Climate change is one of the biggest challenges we face, and understanding requires massive amounts of data. Smart Dust could provide that data on an unprecedented scale. Clouds of sensors could be released into the atmosphere to track air currents, measure pollution levels block by block in a city, and monitor the chemical composition of the air. They could be scattered across oceans to track currents, temperature, and acidity, giving us a much clearer picture of the health of our marine ecosystems. In remote wilderness areas, Smart Dust could monitor for the early signs of forest fires or track the movement of endangered species without the need for intrusive collars or tags. This technology could become one of our most powerful tools in the fight to protect our planet, turning the entire globe into a living, breathing sensor network. So, how does this technology get where it needs to go? The methods of deployment are as ingenious as the dust itself. As we mentioned, one of the most common methods is through aerial release from drones or aircraft. This allows for the rapid and widespread distribution of motes over large, often inaccessible, areas like a battlefield or a dense forest. But it can also be much more subtle. In an urban or indoor setting, Smart Dust could be introduced into a building's HVAC system, circulating invisibly through the air vents to create a comprehensive sensor network inside. They could be mixed into paint so that the very walls of a room are watching. They could even be embedded in fabric, turning our clothes into personal health monitors. The goal is to make deployment simple, scalable, and often completely covert. This ease of distribution is key to the power of Smart Dust, but it's also the source of its greatest dangers. This brings us to the elephant in the room: privacy. The same technology that can save lives and protect our environment can also be used for the most invasive surveillance imaginable. If Smart Dust is invisible, undetectable, and can be deployed anywhere, what's to stop it from being used to watch everyone, all the time? Imagine a world where every conversation in a public park is recorded, where your movements are tracked without your knowledge, where a corporation or government has access to a constant stream of data about your life. Who controls this data? How is it stored? And who gets to decide how it's used? These are not simple questions. We're talking about a technology that could eliminate the very concept of privacy as we know it. The ethical lines become incredibly blurry. Is it acceptable to monitor a city for public health risks if it means tracking every citizen's movements? Experts in technology ethics are raising alarm bells. The main concern is the lack of transparency and consent. With traditional surveillance like cameras, you can often see them. You know you are being watched. With Smart Dust, you don't. It operates in the background, silently collecting data. This creates a massive power imbalance between those who deploy the dust and those who are being monitored. There's a real risk of this technology being used for social control, political oppression, or corporate espionage on an unprecedented scale. Legal frameworks are lagging far behind the technology. We need to have a serious public conversation about where we draw the line. We must develop robust regulations and oversight to ensure that Smart Dust is used for the benefit of humanity, not for its control. The challenge is to harness its incredible potential while building in safeguards to protect our fundamental rights and freedoms. The future of Smart Dust is a double-edged sword. On one side, we have a future of incredible medical breakthroughs, a healthier planet, and safer, more efficient industries. It is a world where we can predict disasters before they happen and cure diseases before they take hold. On the other side, we have the potential for a dystopian surveillance state, where privacy is a distant memory and every action is monitored and analyzed. The technology itself is neutral. It is how we choose to use it that will define our future. As these microscopic sensors become cheaper, more powerful, and more widespread, these questions will become more and more urgent. We are standing at a technological crossroads, and the decisions we make today will shape the world of tomorrow in ways we are only just beginning to understand. The story of Smart Dust is still being written, and we are all characters in it. It's a technology that is as awe-inspiring as it is unsettling. Thank you for joining us on this deep dive into the invisible world that is rapidly taking shape all around us. What do you think? Is Smart Dust a dream or a nightmare? Let me know your thoughts in the comments below. And if you want to stay ahead of the curve on the technologies that are shaping our future, make sure to subscribe and hit that notification bell. Thanks for watching.